Okay, we are live. I don't know why all this garbage is on my desktop. Put this over there. So, we got a lot of stuff to do today. Check a few things. I managed to get the GPU environment running with some caveats late last night. And it's pretty nice, but we have a lot of work to do today. We're on a little earlier than normal. There's Linky, welcome. Right on schedule. And let's just keep it like this today. All right. Lots of stuff to start with. So first thing we're gonna do. All right, we have GPUDrive. And there's a thing that I had to do. I just set a library path in order to make this work. It was really obnoxious, but I got it working. This export right here. I don't know why this path was wrong, but the path was wrong. I tried to run. That's weird. Right, so I tried to run a sweep yesterday, a hyperparameter sweep, and that didn't end up working. But if I'm in the right machine here, which I think I am, then what we should see is we should see some build stuff, which I really wish that this would be cached. We'll have to figure that out. But it will compile some stuff and then it should run in GPU mode. And there you have it. 37-ish thousand. Oscillates back and forth. This can be massively increased, which this is going to be the aim today. We also have some containerization stuff to do. That's really boring though, and I want to start with something more interesting. So let me just make sure I don't have any outstanding messages or anything from the NYU folks. That's really old. Hold on, let me grab the Slack for this. Make sure I didn't miss any messages. And then we have something really cool to dev today. Something very cool today. Freaking Slack. I like how Slack asks you like 4 separate times, are you sure you don't want to use our shitty Electron app? Oh, cool. So I have a reply from the author of Madrona. CPU, they say the CPU backend is already internally vectorized, I know. That's why I'm spawning 1 thread per core. So this answer is not. Okay. We updated thread notifications, nothing changed. Yeah. So apparently it is this file. It has a default argument to the config struct that defaults to 0. I think I have a Twitter DM from this guy actually as well. Let me check on that. Starts num core CPU threads. Is this the default? Is this what I was messing with at the top? He said it was down here, 529. Oh, it's in GPUDrive itself. That's why it wasn't working before. So let me see, so the stream can see this. Config. Thread pool executor config. So I just have to do dot num workers equal 1. And the midrunner will pin the thread to core 0, which is not what you want. So I was actually very close. Let me go get Twitter because I think I have a DM on this. Let me grab that. Make sure this is nothing private. Oh no, this is somebody else. Never mind. Okay. Cool. Okay. Anything else? I forgot to reply to them last night, but I did post on this. Cool. I think I found everything for now. Cool. So what we're going to do today... Oops. Let me find the piece of code that I was linked. There was a cool discussion on this. They linked to me like very similar stuff. Where is it? Threads. Yeah, okay, here's the code. So, they actually told me that this was based off of PufferLib, which was kind of cool to see. Gym Clean RL. And let me see how they're doing this. So, set up ops. Sometimes I wish my advisor would just let me to contribute to PufferLib as my focus. There's some good stuff in Puffer. There's some good stuff in Puffer for sure. You can use Puffer and PR anything that you find that needs fixing or any improvements you make along the way. Okay, this is not exactly what I wanted. Not doing too much RL. Language models have taken over everything, I assume. Shame. They even did the mask the way I did this. They were pretty close. They were pretty close. So, yeah, I know how we're gonna do this. It's gonna take a fair bit of work, though. So, the plan for today, let me get outline at a high level, because I think, do we have some folks on YouTube, right? Oh, shoot, already 8. That's crazy. So here's the plan for today, and let me get all this stuff out of the way so it's not covering chat. Last night I got this working on GPU. Later today, once I get a little more tired and I don't have, the energy to do the higher intensity work, I'll rebuild all the containers, maybe towards the evening, and I will ship this up so everybody can use it. It's not sus. They're friends of mine, and they cite PufferLib in their manuscript as well. So, the thing is, like, people are going to do this until they realize that it's actually incredibly, incredibly easy to work with Puffer and me, because I literally sit here and do this all day. So, like, if you make a binding for Puffer and need help, you're not going to be waiting around for a week for replies. I'll just, like, be like, oh, yeah, sure, let me do that right now live, right? It's going to take a while for people to realize that, yes, it's actually that easy to, like, add stuff, to get me to add stuff. But, anyways, here's the plan for today. Right now, what you do is you specify a maximum number of agents per environment, like 32 or something like that, right? And then it gives you back a big clunky tensor that has all that data in it. But it's padded. So then you have to take all that garbage data that, like, most is padding, send it through the forward pass of the neural network, and keep going until you collect enough real data that's not padding, in order to fill up your experience buffer. Does that make sense? And it's like 90% padding, 90% inefficiency. So what we're going to do is we're going to take the data from the environment, undo all that padding nonsense, and from there, we're going to have just like the tensor be the size of the number of agents, and that should make stuff way faster. And it's going to let us run more parallel environments as well. Now, it's interesting that they told me that the sim internally doesn't actually need to return. Technically, what I'm about to do would be faster if it were in the C++, but that actually will take them time to change. So I'm just going to do it from here. It shouldn't take that long. How did you learn to create GPU drivers? I do not know how to make GPU drivers. This is GPU driving sim, not GPU drivers. This is not my GPU driving sim either. This is NYU's sim. I also write high-performance sims that are equally as fast. I write like million step per second sims, but mine are CPU. They are written in Python and run in pure C. And I did not learn it in university. University classes teach you actually nothing. Like, literally, you get a CS degree, you show up for work, you do not know how to do a damn thing. The only thing you know how to do is teach yourself how to do other things. And, like, probably understand basics of algorithm complexity and system design so that you'll be looking in the right direction. Like, your degree entitles you to another decade's worth of learning stuff. And much more thereafter. It takes a while. I have lots of things that I think that, like, could potentially save people a ton of time along the way. But, like, if I were to give myself from 10 years ago this advice, I know I wouldn't listen. So, I don't know how useful it is. Okay. Uh-huh. Mm-hmm. Okay, this is not bad. Not bad. I do have to do a couple things that are kind of awkward here. So, the first thing I need to do is this reset function here has to go up. So self.obs is going to be m.reset. And then what we need to do is we need to make a function that's like unpad obs. Sure, we'll do it with obs. And then what we're going to do is I'm going to set a breakpoint because I have to do this interactively. This is hard. A few things in the meantime. We have the controlled agent mask, right? I think I probably still just have to do this interactively. This is going to be hard. Oh, I'm dumb. Okay. Oh, this is actually not bad. We have the exact mask we need, don't we? Self. It's a bool? Yeah, it is. So, dot obs of self dot control to agent mask. Ooh. That's nice. 2808. Is that reasonable? I think it's that simple, actually. I think I was just being dumb. Yeah. I think that's literally it. That's actually kind of hilarious. It's like bolt. We're not going to need this anymore. Reset does... self dot obs. Now what we do is... I see. So we just have to move some stuff. It takes me a second of kind of quietly thinking before I can properly explain what I'm doing here. But so what all I have to do is there's this num agents thing. Yeah, right here. That's currently set to the padded value. What I have to do is I have to reset the M so that I can get this shape here. And it's just going to be self.obs.shape. Okay, and then this is now going to be self.numAgents. And now I actually have appropriate size buffers, right? We're not going to use that function, but I'll leave it there for now. Episode returns is now going to be a flat buffer, I think. I might need like agents per env or something, right? Yeah. We'll think about that in a second. But for now, at least, controlled agent mask is a .cpu tensor. I don't want it to be a CPU tensor. I want this to be a GPU tensor. And then this will be .clone CPU, not NumPy. Okay, so obs is self.env.get obs of self.controlled agent mask. Rewards, self.controlled agent mask. Ah. Self.controlled agent mask. We can actually do dot bool like this. Terminal. Okay, this done worlds thing is a little tricky. This is the portion that'll be hard. Let me see if there's anything else that's gonna be hard. Does not look like it. So, shit. I think I need to do this slightly different. Did I just get a reply? I think I was pretty close. I think I just need to set this terminal a little different. So, what we do is done worlds is going to be terminal. Yeah, this tells you what's done. And then you're allowed to do .cpu. I don't like that I'm moving this multiple times. That's fine for now, though. No longer need these two lines. Because, we no longer need those two lines because, we now have flat data. And it's so tricky to figure out how to make these things. Like this, it's conceptually not that complicated, but it's very easy to make errors and very hard to catch them. So I tend to just go very slow and move very carefully with this type of stuff. Get infos. Done worlds, okay. I might want to run this on CPU a little bit. We'll see. Just to avoid the compile time for testing. What happened? Okay. Oh yeah, NVIDIA is wrong. That's fine. Gotta love bugs that look like that. It just takes an obnoxious amount of time to get used to finding them and recognizing them. Yeah, this is easy. Just have to define the env IDs according to the agent IDs instead of according to padded agent IDs. Value. We're still getting bad values. I suspect because we have size mismatches somehow. Let me see. Interesting. Welcome, YouTube folks who like watching me debug random simulation code. All this stuff will be publicly available as soon as I get around to committing it, and it will be on the puffer tank container as well, so it will be very, very easy to play around with. I think it's like a 12, 13 gigabyte container, last I checked, but you know, once you download it, it's very easy to use from there. I spent a little extra time last night to figure out how to get this to run on GPU. Though I don't know if it'll be faster on GPU. We also have the potential to make single thread CPU work today. And if we can do single thread CPU, then I can use my own multiprocessing implementation, which should be faster than their multi-threading. I also kind of want to do that because the creator of Madrona messaged me that, like, hey, you know, anything you're going to do on Python with the vectorization is just going to be fundamentally slower than the C++ multi-threading, which I know that's not true. It kind of makes me want to show that it isn't. Blame Gil. See, the funny thing is that my stuff is not limited by the Gil because it's like essentially zero overhead Python multiprocessing because of the I found some tricks with shared memory. I think they're like a few. It's like I think it's either high single digit or low double digit microseconds overhead on the main thread that I couldn't get around. That's it though. Which is really funny because it's like, what the heck do you mean performance engineering in Python? Yeah, I mean performance engineering in Python. Wouldn't it be faster in C++? Well, no, because it has to work with Python objects. You'd have to copy all the objects a bunch. Unless you're really clever. Something went weird here. Compiling out the GIL. Nah, man. It's not a problem. We're fast, okay? We're fast. Okay, that actually tells me what I needed to know. That this is failing on reset somehow. So I'm assuming that these are just not the shapes that I think that they are. Oh, did I do mask wrong? Yeah, I did mask wrong. My bad. numpy.ones. Thoughts on no-gil? I actually don't know if it's going to help Puffer or not. It looks interesting. I actually don't know enough about how hardware interacts with threading to be able to answer that. Because you're technically like supposed to have 2 hardware threads. I don't know if could you actually ever get speedups like on pure compute bound workloads? Do you ever get speedups equal to number of hardware threads instead of hardware cores? Because it's like 2 hardware threads per core or whatever. I don't know if you ever get that. The multiprocessing we have is very, very optimized. So I don't know if we get any additional benefit by going to threads. It probably makes some stuff simpler, but then again, like, I don't trust the Python threading primitives to be fast enough for what we want. So like, even like the communication, like the threading communication, which should be instantaneous because it's in the same memory space, like if those functions have 10 microseconds overhead, my multiprocessing is going to be faster. I mean, to give you an idea, I didn't use pipes, send and receive from pipes, because there was 40 microseconds overhead, and that was too much. So I got rid of pipes to save 40 microseconds, and that was a huge improvement. I like performance engineering. Multiple threads. Do threads scale? I don't actually know this. Do threads scale above the number of cores in your do threads get you performance above the number of cores on your machine because they're technically like 2 hardware cores, hardware threads or whatever? I don't understand the hardware side that much. I know that processors typically they have 2 hardware threads per core or whatever, but I don't actually know what that means in terms of the optimization. Is that truly 2 things running at the same time, or is that just like optimized like caching, like switching or whatever? Linky, that's not what I'm asking. It's whether there's hardware. It has nothing to do with Python. Do threads scale above hardware CPUs? I don't know. There might be a factor of 2 and there might not. Okay, this we know how to fix this. It's kind of gross though. So this is going to be agents. Yep. So what we're going to do now, we want to do indexing on the CPU, not the GPU, right? Because Puffer is going to return NumPy, at least until we optimize. I guess we'll optimize in a bit so it won't matter, right? So yeah, for now what we'll do is, this is on GPU. To self-device. Then we'll do self.actions equals action. And we do self.action. Okay, so what this is doing is it's taking our actions that are flat data and it's putting them back in the original padded data that the C++ environment expects. Tuple index out of range because stupid. Oh, everybody keeps talking about this bug, like this error message, but you get used to it pretty quick. It's just the tuple index. Shape of mask. Not match. Okay. Broke my terminal. Nice job. Hello. Welcome. Currently, we are working on accelerating this learning process by making it not return 90% padding. That is the current state of affairs. And it is a little tricky. Not too bad. I'm hoping we get good perf out of this today. They told me that they get... this is this linker. They told me that they get 50,000 steps per second performance, which if their sim actually gets to be 1 million, then that's quite bad. If we can get 1 million out of the sim, then I can get several 100,000 out of the neural net. Could be really nice. You can do it. Thank you. Yeah, we're gonna have some cool tech out today. Okay, so the issue is that this needs to be like this. This is the one place we actually need. The actions buffer has to be padded. And then it's the this buffer that's not padded. Action shape is 2800. That's just data type. Absolute Madman with Torch and Vim. No, the Absolute Madman was me using no plugins standard Vim for like 7 years. From like high school through, I don't know, up to like 2-3 years ago. This is at least NeoVim with a whole entire 2 plugins. How do we not have a soft... Cool. I probably should be running this in the other window so I don't have to be tabbing all the time, right? Test. Okay. Oh, train vec native. No attribute live agent mask. Did I get rid of this thing? Yes, I did. Mask. How do I want to do this? I'm surprised you don't tmux with Vim and Vim open in a pane. I used to have i3. Tmux is too much bloat for me, to be honest. The only thing I use tmux for is keeping experiments alive. Did you see a tweet about RLHF on not being RL? Yeah. Well, everybody knows that like RLHF is baby mode RL, right? Like it's a totally different use case of it. It really doesn't leverage many of the advantages whatsoever of reinforcement learning. And I don't agree that it's AlphaGo type systems either. I don't think you need explicit search for RL to be useful. I think like learning from scratch without search is fine as long as you have stupidly fast simulators. Which is what we're building here. Building stupidly fast simulators. And every so often, helping out with other people's. To be fair, a lot of my conviction on RL, it depends on this one Schulman paper being correct. So I don't know, if anybody wants to go see if they can find any errors in the single agent scaling laws for RL paper, let me know. But it matches my own intuition, and I think it's probably good. So this might be it. I keep forgetting I have this other tab here. Only thing with applying RL to LMs is how you find a reward system. Not really. It's like, the thing is, RL is really good at just sucking up unlimited quantities of data, whereas language models are really bad at that because they're big and clunky. They have lots of parameters and need lots of compute. Like, language models are trained on a pathetic amount of data when you think about it. Like, there's basically no data used for training whatsoever. Like, oh no, we use a whole 10 terabytes of data. It's like, cool, I do that on one GPU in a day with RL. They scale with parameters instead. What'd I do? Oh yeah, this is a little obnoxious, isn't it? Maybe something like, yes, it would. I really miss i3. It's massive time sink, yep. There is technically one for Windows as well. I'm just too lazy because it breaks stuff. It was kind of made just for me as well. Like, it's the exact thing I'd want to use. I just am too lazy because it's not part of the OS. I don't know, I could download it. It's pretty cool. It's like the exact thing I would want. It doesn't have, oh, did they add this? Yeah, they added a split. Okay. Cool. I like this thing. I played with it for a bit. I don't know, we'll see next time I want to screw around with something. I don't mess with my tools too much. But yes, I had the undergrad years for me were like ultra try hard, Arch plus i3 on custom built water cooled desktop that I, hacked together thing. Would be great to see yet another compatible with the Omniverse M's. Let me see this. This NVIDIA? Oh, this? There's no way these are fast, right? Wait, is this what you mean? There's no way this thing is fast. Right? Oh, Isaac. Wait, this? Oh yeah, this thing. Okay. Yeah, this is potentially more doable. I could probably add it. We'll see. Configuring Linux is a huge time sink. It's the thing is it's the type of thing that's good to do when you're new to computer and you want to learn stuff quickly, but it rapidly becomes a waste of time after. Fast as GPU goes. Yeah, if it's the Isaac Sim one, then yeah. There are some people that I have that might be interested in doing that. Running headless is good. Well, mandatory, really. Hold on, let me think about how I want to do a thing with this. Can I just do... Make the live agent mask like this. And then we'll do this here. Does this work? I think it does. Whoops. So used to tabbing this way. From Ubuntu to Nix, Ansible. I really like the puffer stack that I have here because it's a Docker container that I can pull from anywhere, and then I just have my NeoVim defaults in here. So that's my whole editor and everything. So I basically can just use this container from anywhere, and I'll always have the same consistent dev environment. Oh shit, we actually have this thing running, don't we? And way faster. Well, okay. Do we update self.mask though? We don't update self.mask anywhere, do we? Yeah, because this has to be changed. Hold on. Data density. Yeah, no, that's not going to be that fast. There's no way. I fought Docker for a long time, but Docker is the way. Like, yeah, people say, oh, I just have good conda, I could have VMs. It doesn't matter. They take too long to spin up. Docker spins up instantly. Any books, resources you'd recommend? Start doing stuff, right? Like you read papers. Maybe there's like the OpenAI spinning up stuff, but then like you've graduated. Congratulations. You start actually working on stuff, right? Mm-hmm. Like I didn't read a bunch of books to start doing RL. Like I read a decent chunk of papers and I wrote a lot of code. And it is much, much easier nowadays to just start writing some RL code than it used to be, believe me. Much easier. Back in my day, we had to work off of OpenAI's absolute garbage baselines repository in order to do anything. That was fun. Let me tell you. It was equals self.live. Well, we've been thinking about M's were always a weak point in RL. Yeah, not anymore though. Not anymore. Okay, so now the really cool thing about this data density this is just going to be finding problems to try and build. There have been lots of people in here that have been just like picking up Puffer and jamming some ultra fast environments. If you have like some software E background at least. Noah's been doing this awesome fast breakout thing. There's somebody else in here. I'll know him when I see him. There's another guy. It might have been Nathan, who was starting on Tetris. Use like just make million step per second M's to contribute to Puffer, right? Okay, so 17K right now, but this is with CPU mode. And with GPU mode, have you seen the Puffer cluster, Pablo? I present to you the Puffer cluster. This is literally what we run stuff on. This is it. Oh, oops. It's CUDA, not GPU. They support a lot of different devices. That's kind of nutty. Didn't help as much as I thought it would. So we're not getting, we're just not getting the perf out of the environment, right? So we gotta write a profiler, maybe? So, you might say, Joseph, you say that you don't ever use code complete for stuff. Why are you possibly code completing all of this stuff and it's gonna write a whole bunch of garbage? Well, viewer, it's code completing with my own code. This is my code. It stole this from another file on the same project. Ugh. It didn't even do that perfectly. Wow. Puffer clusters near top tier. That's right. We got the puffer cluster. I told you I want to build that thing out way more, though we might do it with AMD after the whole Intel debacle. We'll see once I start getting revenue for the company. We'll see how long it takes once I launch to start getting some clients, but one of the relatively early goals for Puffer is going to be to go from a $30,000 cluster to a $250,000 cluster. That will give us that'll give us like a pretty decent chunk of compute to use. We can sponsor a ton of cool open source work with that as well. Can imagine the sweeps. Yeah, that'll be nice. We gotta get there though, which means people have to follow the Twitter and people have to star Puffer in order for that to happen. Star the Puffer. That's really dumb. Huh. Maybe I shouldn't have named my model files torch.py. Cluster computing with fiber uplinks. Yeah, but that gets expensive. Then you go from being able to buy 50 machines with 250K to being able to buy like 2 machines. Basically would all have to be custom outside of the boxes. Which is why the desktops are so nice. How do I get around this? You'd have the desktops, then upgrade. Oh. You just want fiber upload speed? Is that all you want? We're not wiring the boxes together. That's when you get NVIDIA mad at you. We will absolutely have better transfer speeds, though. Um, This is so obnoxious. Can I just like... Oh, I have some replies. Okay, well, how do I get rid of this dumb bug? Can I do like... This is so stupid. Does this do it? GPUDrive. What? I don't have a torch. Import what? Import torch? Oh. It's not doing it. Swat it. I don't want to have to go rename all the model files. Yeah, they shouldn't have been named torch.py to begin with, but just like all these garbage beginner Python blogs. I'm gonna just rename it for now, and then because I'm not gonna just waste time doing this. No module named PyGPUDrive. Oh, geez, this can't even be run from. Yeah, it needs to be run from. Okay, it's really obnoxious. How does this not exist? Oh, because it's gonna do the underscore net. Should I just make a separate test? Let's just make a separate test. Yeah, I should have just done this a while ago. This is silly to be stuck on for any amount of time. Cannot import. Really? Why does this thing not importable? Oh, because this is just me being half asleep. Okay. There. Now this works. We get a test. And somehow because I didn't reset it. Should have been a reset up here, no? No. You need to still reset the env. Drona has a nav mesh. That's cool. Okay, this gives us some perf. Only 41K. So something is definitely wrong because I'm not getting the... It's the environment itself that's slow. Let me do a cprof test. This one doesn't have it. Test performance. env 20. And we can just do this. It's fine. Let's try this. So maybe we can figure out where we're losing all our perf. Make sure it's actually not in the wrapper before I tell them, like, hey, not getting the perf. Well, it's definitely using this. Okay, so... No, it's all in step dynamics pretty much. There's a little bit of wrapper overhead. Let me kill all the Python processes to make sure. We'll see what we get out of this. Oops. Hey, just jumped on the stream. Welcome. That's actually perfect timing. I did the thing that we talked about. I have dense data coming out of your environment now, not from the C++, but at least from the Python side. So perfectly dense. Exceptions being for agents that die, but this, which ends up being a lot of them. But I'm still having issues with the perf of this. Unless this test comes back faster, I'm only getting like 40,000 or so steps per second out of the GPU environment itself. So I don't know if I'm doing something wrong. Probably I have some config settings. Export, thank you. That is what I've wanted. That's very nice. Let me actually add that before I forget to... Oops, one. Okay. Remember to delete the cache file. Ah, I see. And /GP. Okay, I see. That's cool. Ah, stupid thing. Depths. Cool. So now I'll make sure I add that in. Wrapper is slower than the raw sim. The PyTorch wrapper? Or what wrapper? 42K is not like... We can't do anything with this, right? We need to get... Can the sim return... Gym? What gym wrapper? Okay, the other thing I was confused about is this is not a gym environment in the first place. Like, gym is a single agent API. And it returns NumPy arrays. So I'll show you what I'm using. GPUDrive env torch. I'm using env torch. The only thing I've added is I've added some like not numpy nans or whatever, some wrappers. But I did a C profile run as well, and it's all in step dynamics, actually. So if we're all in step dynamics, then I assume that the wrapper is not adding very much overhead, right? This sim is the actual underlying sim, right? Initialize simulators. Yes, you're right. Okay. So how do we get the million step perf? Like, if we can get the million steps if I can get the million steps like reasonably soon, I can have this thing training at several 100,000 steps per second today. I'll show you what I did on the wrapper side. You might like this. This is with an LSTM as well. Environments, GPU. Okay, so what I did was I took your environment and I took this controlled agent mask that you have here, and then the OBS, I select controlled agent mask out of the OBS, so I only get the agents that are not fundamentally padding. You still end up with padding for dead agents. I can't do anything about that, but you don't end up with padding for the non-controlled agents. Which is pretty nice. What's the current train perf as well? Let's see. Multiple params to tweak. 3. But like, so Daphne told me that you profiled the sim with you profiled the sim with masked, with masking taken into account, right? More details on Slack? Sure. I have that open on the other side. Let me grab that. If you have anything to send there, that's good as well. Threshold. I have 256 worlds, which ends up being a maximum of like 2,800 agents. So I can double this, but I mean, we're like more than an order of magnitude off, right? So I'm assuming that the settings are like totally messed up somehow. There's also the option of me trying to get the CPU single thread mode working. I can mess with that as well, potentially. I'll give you a minute to write some initial thoughts. I'm going to go use the restroom. I'll be right back. Yeah. Million FPS comes from dense utilization of agents. If you select files with more number of valid agents, you'll see big speedups. Sim scales number of agents. With 32 agents, you may be able to fit in more worlds. Okay, so great. How do I select files that have... How do I do that, right? Like, that's what I'd like to do. Perfect. Is there like a strategy I can... is there like a parameter I can use to like set the number of agents or whatever? Like what settings did you guys use when you were benchmarking it? Like I can just use that setting. That will probably be more manual. Yeesh. Benchmarking, two different scenarios. Valid agents from random selection of files. And considering padding agents to be valid. Oh. If you're considering padding agents to be valid, then this thing is like an order of magnitude slower, at least. There are files with 128 valid agents. I thought there are not very many. I mean, from what I can see, some of these default files have like 2 valid agents. I mean, I'm assuming that this thing is linear in the number of actual like agents or whatever. So like, is it possible we can get dense data out of the CPP sim itself without wasting time on all this padding? I mean, around 20 to 40. Yeah, I saw. I don't know if that was in the paper, but Daphne showed me the graphs. I think Daphne told me that you weren't considering padding to be valid though. That like, because I see that you have code that like goes through and counts the number of valid agent steps. Also, the fact that you guys were training at 50,000 steps per second in the first place means I think I'm missing something, because you'd have to be simulating... The way SB3 works, you'd have to be simulating, right, substantially above 50,000 valid agents per second in order to be getting that, and I'm getting 4,200 on a 4090 here after doing optimization as well. Is there something I have to do with this episode length parameter so that it gets applied correctly? I don't see it actually being used in the config anywhere or anything, but I didn't see it being used anywhere other than for generating videos in your code either. I'm just looking for stuff. Okay. Bottleneck CPU or GPU? Take your pick. It's the simulator. It can run on either. Though it looks like it's the setting of these. Episode length is fixed to 91 steps. Okay, so I don't have to deal with that. Cool. We do terminate early as well. I have the early termination if it's empty. Unless I messed it up. Same as I did with Neural MMO before. This K unique scenes, I couldn't figure out what this was. I couldn't increase this. It would give me errors. So I don't know if there's like a way to load different files or whatever. Have you profiled the sim? I haven't profiled the underlying C code of this sim, but yeah, I've profiled to make sure I'm not just wasting time in my wrappers. It's like 90+% of the time is just in the sim. I already did some settings to reduce padding. I mean, I can probably do this to 512. Because we only have 2,000 agents, 2,800 agents. So maybe this gives us something. Okay, that gets us to 68,000. What do we get on a CPU with their default VEC? I want to see the perf difference with CPU. $20K. Do I think my CPU VEC is so much better than theirs? I kind of do. I mean, I kind of do think my CPU VEC is good enough that it might be worth doing. I'd have to get like 3x their perf. Am I crazy for thinking I can probably do that? But you know, the thing that's hard is the padding. My VEC is not set up to have variable numbers of agents per worker. You can have variable per environment, but not per worker. I don't know if the sampling's deterministic or not. That would be substantially more work. Let's start with this for now. So we get 20K CPU, 68K GPU. Oops. Okay. Well, that's already a little bit faster than the reported train performance. If you guys had 50K, we're a bit above 50K now. Data density of 30%, meaning most of the agents are dead. It's a little bit annoying. It's about 50K, really. you give me the files you're using, I'm using your defaults. Like I don't have, like this is what I have right here. This is just from your demo code. Selection K unique N, K unique scenes. If you have a better setting, I can pretty much immediately make this faster. Using 3 files padded. I don't know why I would be doing that, but I guess if that's how it is. I mean, I would like to have, 512 files, ideally, so you have a nice mix of data. All of which would have, like, some reasonable number of agents. Data folder only has 3 scenes. How do I get the rest of them? I thought there's a big data set, isn't there? Full data set link in the... Okay. So I have to download that in order to... Cool. Mini version with 1,000 files. That should be good enough if I can actually get, like, reasonably dense data out of it. Let me see. Mini one is... Okay. And copy this. With their instructions, let me see. Path to directory containing the files. JSON path. That is outdated. Oh. Is this the right link though? Like, what, where should I put this? Can I, like, just curl this here or no? Oh, JSON, okay. I don't know if I'm downloading this thing right. I don't know how you use Dropbox links from CLI. If I can't curl it, we'll see. Curl. Did I get it? Apparently not. Oh. Nope. W get it apparently. Always W again. Pass in a list of paths. Okay. Well, I can do that. I think Daphne said I can probably like open them, like write some script to like filter through these and try to load dense ones. Maybe this is working, I don't know. But it looks like we're gonna have to get the data set, go through the JSON. Gonna drop off. See you around, I'll try to get this working. Yeah, we can get like the number of agents in here. Probably that'll be faster. We get anything from this? Man. Let's see. Folder key. SCL. Oh, wait, it's this. D. What in the heck? Why can't I freaking do this? Is it share SCL? Heck. How's it going? It's going all right. We got it working on GPU. I'm just trying to figure out how the heck to get this Dropbox data set with curl. Drive me nuts. Does GPT know how to do it? This is like might be the one exception where GPT actually can. We'll see. Does GPT? Why do I think that this is not going to work? Something just tells me, you know? Does it actually work? I guess I'm dumb. Okay, did something useful for once. Broken clocks. Broken clock is right twice a day. Alright. Uh... It's a lot of stuff. What did I just make this new? Okay, so it's going to be mini data formatted JSON v2 no TL train. A good path? Okay, so that does run. As for speed, we are going to have to make a little script here, I think. Okay. Import OS list files here for open. F data's f.read. And I had, hold on, let me figure out where. I think I got I have Twitter DMs or something for how to do this. Because we need to go find, well, the goal here is to go find data files that aren't all padding. Yeah, I do have this in a DM. So you can store the names of files with greater than n vehicle occurrences. Okay, how do I do this? Data. Load. Oh, is it not? Okay. Yep, that's a lot of data. Files with n vehicle occurrences. Holy. So what is this one? Position. A whole bunch of positions. Type vehicle. Greater than n vehicle occurrences. So data object, vehicle, min equals 16, max vehicles 32. Good files. So what we're doing is we're just going to filter this. Key error objects, really? Key error. Guess we do this. And this does 1,000 files. So is that 240 lines? Yeah, 240 lines. Okay. So let's see if this works. Path should be a string, not list. So it wants a directory. Okay. That's actually easier if I think about it, right? Does this do it? Name. What does it think that this is? Hold on. It's just f.name. I should have just guessed. And actually it has the path in it, doesn't it? It's literally f.name. Very nice. So I don't need this anymore, right? Mini good files. Interestingly, not any faster. I should be able to increase this though, right? And now it takes a long time to open all the files, right? It's actually slower. That's not good. Data density is higher, but the sim is just so slow. Have you ever worked in intersection of computer vision and reinforcement learning? Doesn't that mean just like any environment ever that uses image observations? We have lots of those. Everything's exactly the same as in, the rest of RL. It's just that it's slower. Okay, I think that they had max objects 128 before, right? That's what they had. So let's Let's do 128 max agents. Well, before we deal with this, let's see how many files they have that actually have this many. This is a lot of vehicles, right? 100 to 128. How many do we have? How do I know how many files this is? I actually don't know how you do that. 1, 2, 3. At least 64 files, right? Let me think. How much time does it take to combine my knowledge to reinforcement learning after I become good at computer vision? Fundamentals of ML and models transfer. The thing is that like RL has a giant additional engineering component from the simulations and such. That's the main thing. Like, basically, you can go from when you're good in any field of ML, you can go to any other field of ML in like 2 months. But with RL, like, the thing is the work tends to just be so much more engineering heavy. So it's like if you're a good software engineer, or at least if you write good code and you have a good knowledge of computer vision, you're probably in a good spot. But frankly, it's the engineering component that's harder in reinforcement learning. At least for the type of stuff that I'm doing. We will have to recompile their repo. Where's the commands? There's a flag I need. Cool. Recompiles, good. Aborted. Well, shit. How's that possible? I didn't do anything weird, did I? Max. Does this need to be 128? Maybe. How the hell is this not compiling? Oh, because I'm dumb. Let's remake it. Compiling. We'll see whether this compiles everything. I think they have a lab meeting at the moment. Maybe they'll be back in a bit. Still a few questions for him. Okay, perfect. It should not match. Now what we do is we set this to 128. Numworld's got to go down to 128. How is it slower? Don't know. Take care. Good luck. How is it slower? Well, something's wrong, right? Because the sim density is too low. So we should just assume I'm stupid instead of I don't know how the stupid Slack code block. Oh wait, this is how it works. Two separate buttons for code versus code block. Maybe it's in the file somewhere. Data. I don't know what this is. Nothing. Okay, roads. A lot of roads. But this is not, again. Type vehicle. Use. Position, width, length, heading, velocity, valid, goal, position, type. I don't see it. Yeah, I don't see it. So this is what I need in order to be able to filter. It's not in the file name. TF record. I thought that I was told to look for the number of objects. Maybe that's not how it works. Check. We'll check the Twitter. So I was told greater than n vehicle occurrences. Okay, actually I'm doing it right according to Daphne. I don't know if there's anything else. Let me see. There should be something else to this, don't you think? Let's put a breakpoint like here. Maybe. And GPUDrive back native. Yeah, okay, so this is freaking wrong because maybe I'm just being dumb. Let me see. Mini data, good files. Unique scenes. Maximum objects, 128. True, true, false, true. Yeah, this is very sparse. It looks like there are a lot of vehicles, but we don't control very many of them, maybe. Cont agent mask. Okay, maybe I can just find it in their code. Oops, over here. Makes me sign in. Have an account with us. Okay, so get controlled agents mask is what we want. Get controlled agent mask. It's in controlled state tensor. And then it's controlled state tensor. We're going to find all the way through their code, however long it takes. Make a printer. Oops. Bindings. It's got to be here, right? Export tensor. Export tensor. Controlled state is what we're looking for. Okay, well, I know what I'm looking for now. It's controlled state. This. Control mode controlled. Level gen. I'm looking for where they set this. It's got to be here, right? Control mode dot bicycle. What? Is valid. Get response type. So max num controlled vehicles. I didn't mess that up, right? Ooh, I don't have max num controlled vehicles anywhere. Interesting. Is there a config for this? It's 128 by default. It is 128 by default. Oh yeah, look, I have right here max cont agents. It's going to be the same as the max num objects. So we don't have to worry about that. What happened here? I had this, yeah, here. Wait, where did my thing go? Here, this one. Agent init type is vehicle, which it is. Agent init.valid. Okay, well, we're gonna play with some other stuff then, because this is kind of weird. So do I have any replies? Can't read from the files easily. Wait, you can't read that from files easily. Check if the final x and y is less than 3 meters from the initial x and y. Organizing at RLC, or I would add it. Okay. I forgot that started. That's not that bad, right? Wait, less than 3 meters? Oh, I guess the scale is different. That's fine. I need a grumpy puffer emote. For any time I have to do stuff like this. That'd be good. Okay, L2 less than 3. So now we're just going to say if it's less than min vehicles or greater than max vehicles, continue. And then what we're going to do if pause or start position 0 goal. Okay, compute 2. Distance 3 meters. Okay. Agent is valid at the first time step. Freaking data density problem. There is a valid dict. Oh, for each time step for each agent. Object 0, valid 0. Okay. We get far fewer files. 1, 2, 3. Let's see. 1, 2, 3, 4, 5, 15, 16, 17, 19. So we only have 16 scenes, I suppose. Oop. Don't need this. Sim density is still low. Very weird. Distance is 0.2 meters. Oh, it has to be more than 0.2 meters. Okay, I did it backwards. Less than. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 16 by 3 is 48 files. We'll do 32. We're going to make this thing work today. Data density is still low. Can be switched off. Parked vehicles. I think I'm doing something wrong. Let me... What happened? I don't know what happened. I think I hit a Control C. Record paths. Let me see. How am I doing this? Num vehicles. Oh, I see. I have the logic totally freaking wrong is why. Continue. Let's do this. I have this logic just totally freaking wrong. All right. So object start goal L2. If it's too close, not valid. You continue. Otherwise, vehicles plus equal to 1. Zero valid vehicles. They said that sounds correct. All right. So this is 20 files. Roller coaster here. 64. So 64 is going to be the max. We'll do num worlds. Can do what do we say? Maybe 256. And then we'll do 16 unique scenes. 16 unique scenes. And yeah. 64 max agents. Remake the code. Remake all the code. Get rid of this. Does this give us anything? What? Oh, this is the this is fine. We know what that is. That's just hold on. We got to export some stuff. Okay. Haha. Let's see. We make progress. It's flippy. Kind of flippy. What's the average? If I just do this. It's cool though. So this does help. This definitely helps. What about the densities? Data density, so real data density of 30%. And simulation density of only still 20%. Why is the simulation density only 20%? What the heck? What happened here? Oh, I'm just... Where you get brain damage from doing this too long? This should not be possible. It needs to be higher density than this because... Let me make sure I'm computing this the way I think I am. Sum of mask over num worlds for max num objects. Let me put a breakpoint. I'm gonna make this stupid thing actually be million steps per second train. Come on. You gotta be fast. New standard in reinforcement learning. Like 500k min train. Come on. At least give me 1 billion steps an hour. Can I get that? Right? That's so much to ask for. Yeah, ridiculous to ask for by standards of 2 months ago, but RL moves fast. Okay, so this is a data density of about 2/3, which is what we expect. So, okay, no, this is denser than I expected because it's... No, because they're dying, I think. Controlled mask dot sum weight num controlled over num agents. Oh, obviously that's going to be... It's not num agents, it's over these shapes. %64 control density. And then the data density depends heavily on resets and such. That's why it's so variable. Let's see how many agents we're getting. Maybe I can optimize this. $10K agents is already big. That's already big. We'll have to sweep over that. Whoops. That's not wrong window it. So I'm trying to think what we value more, density or... I mean, I can get it a little bit higher by doing a more aggressive cutoff. Do I really want to do the full data set right now? How big is their full data set? Oh, that's like obnoxiously large. Let's just go back into... Let's do 48 plus. Do we still get enough files if I do this? Not really. We can do 5 files though, right? Oh, it's so close to being there. Look at that. $200K. This is $200K. I should really do the full data set, I guess. That's like so obnoxious though. That's a lot of stuff. And I'm gonna have to like redo the transcript or the processing script probably. I could also just go down to 32 and use like a very narrow range in there. But I feel like is it gonna be the case that number of objects, maximum number of objects in the scene we control? Do we even use this? This is really just max controlled agents, I guess. Do we want a subset? Trying to think. How should I do this? What if I just load their biggest scene? That'll be a good thing to do, right? Just load their biggest scene. big is the biggest file? $60. Well, that's not right because we didn't do... How's the biggest possibly 60? That's funny. We'll do biggest. Probably leave it at 64 like this. Biggest file. Unique scenes is only one. Whew. Look at that. Now that's some speed. So let me think 60 times 68. So we'll just do 64. 64 worlds. How's this do? Slower? GPU doesn't like that, huh? Stable, though. Stable 250. $260. About the same. Was this the like way higher for some reason? I don't think this is actually higher. I actually don't think that this is higher. Hold on. If I just increase the batch size to like 64K, 65K like this. And do they have update epochs for one? Yeah, they do. I think this will give us something more stable. Because the estimates are over the whole batch. It is quite fast. Why does it spike up so high? You gotta go check their paper. Yeah, because this is definitely slower, right? It's a nice clean 250. Let me see, where's their paper? Where is your paper? Paper. They have scaling things on here. Right, so number of parallel environments and steps per second. $256 worlds on a consumer GPU. 4080. Man, don't make it easy for me, do you? Really don't make it easy for me. Over 1 million FPS, 512 worlds. Average agents per scenario is 60. Okay, so spot on with what they say. You know, let's test them on that, actually. Let's test them. 512. It's 512 worlds, right? Do I think I can handle 512 worlds? Let me think. 60 times 512. 30,000 forward batch? It's pretty large, but... Oh yeah, there you go. 1.1 million. Their claim is correct. It's so freaking variable. Just hopped on for a few minutes. How's it going? I reproduced your 1 million steps per second plus by selecting just one world that has the most number of agents in the data set, which is 60, which is the average number that was used for your benchmark as well, happens to be. And it's very volatile, but we got 300,000 steps per second training at the moment. So that's 6 times faster than your baseline. According to Daphne, was 50K. This is with 512 worlds. And it could be made faster if we had the full data set, I'm sure. It's also very volatile. I think we need to, like, desync some of the worlds. Are you resetting? Doesn't include reset times. Well, that's should include reset times. I'm just resetting when all the agents are dead, right? I actually did manage to get your FPS over 1,000,000 with resets. The reset should definitely be included in an ASPS calculation. So I do get your over 1,000,000 claim, which is good. That reproduces nicely, but I can't reproduce it with like random files. It only reproduces if you actually have a dense file. Reset is higher. But I'm not resetting all the sims, right? I'm only resetting individual sims when they're done. See, I passed the index of the done world. Or is this only going to occur at the end of the episode? I would assume that this would occur when, yeah, it occurs when all the terminals... I'd assume that's when, like, all the agents have crashed or the world is done, right? Reset doesn't happen until you call step the next time. But it only resets the individual env that I'm calling reset on, right? It's not resetting all of the envs or anything, right? World, yeah, that's fine. That shouldn't screw with my timing. My timing just runs through this whole thing with random actions for 20 seconds. $400,000 SPS at the end. I think it's 300k average train. 1 mil sim. Very volatile. Probably can figure out how to train this. Oh, while you're here, do you know how to make this thing not segfault when I close it? Because I can't run sweeps because the thing doesn't close cleanly. If this would close cleanly, I could run this through carbs. At 300k, that's 1 billion steps per hour. So I can train 1 billion steps per hour per GPU with the sim. Individual worlds being heavier to reset. I have one world. I have one world that is 60 agents. I took the biggest file I could find. 60 valid agents. I logged density and stuff as well. So apparently they're not all actually valid in your sim. Based on these, it says 87.5 are. 87.5% of them are. So I was expecting 60 agents, and I'm only getting like 55-ish or something like that. Data density is actually... Ooh, data density is 0. That's sketchy. I will have to look at that. Sim density... Okay, something is wrong then. Because these should not be 0. Yeah, something very wrong. Oh, hold on. Self.live agent mask. Well, I'll figure that out and see if we're actually getting the SPS I think we're getting. I would like to know how to make this not crash. I think I could figure the rest out. I defined a close function and just called env close. That doesn't seem to do it. Still seg faults. I was using subprocess. That's funny that you were using subprocess because this env breaks in subprocesses by default unless you use spawn instead of fork as the default method. I don't know how you got it to work there. I don't think that there's a way, if the thing hard seg faults, I don't think that there's a way I can run sweeps on it. Like, it needs to be able to exit cleanly. Interesting. Well, I can't do that for this. Yeah. I'm not going to be able to do that for this, though, because, like, I need to hook this into WandB. Right, WandB manages the subprocess for the experiments. So I need to figure out how to have this env exit cleanly if we want to have sweeps on this. I mean, I would think that that would also just be a good thing in general for the environment, because this thing, like, it'll crash your shell constantly. It seg faults basically every time you exit. Like, it'll screw up debugger sometimes. There's a little bit of, there's definitely some stuff going on. Oh, interesting that it's not... Oh, all the worlds are finished at the same time. Interesting. So that's why the data density is like this. So I'll have to calculate this differently then to get the real data density. Okay, that's my bad. CUDA context needs to be owned by one process. Needs to be passed to any spawn processes. I'm not even running this in a subprocess now. But yeah, unfortunately, like the main thing I wanted to do with Puffer with this, right? I can give you like the super fast training config. So that's like a, right now I have like a 6-fold train improvement. We're using decent configs with Puffer. Probably you can find, if you go through the whole data set, right, with this script, you can find enough environments that are dense to get even a little higher than this. I'll see if I can manually find some hyperparameters maybe that are like okay. But yeah, like carbs automated on this would just be, and you'd be able to run 100 experiment sweeps on this in, yeah, 100x 10 mil would be an hour. Billion steps an hour, 100x 10 mils an hour. 10 hours for 100x 100 mil. 10 billion steps of experiments. How can I reproduce the seg fault? Does it not seg fault for you just like whenever the program exits? Like whenever you do anything with it, it doesn't just like seg fault? Like literally program finishes seg fault. Not really, no. Okay, well in that case what I'll do is I'll finish this up. I'll try to get all the container stuff pushed together. I'll figure out how I can automate that so that we have like the config or whatever on Puffer, and then you can use the container. You have seen it? Okay. I wonder if this env.close has anything to do with it. Like if you're just not allowed to close the env. That would be really weird though. Here. Close doesn't do anything except call delete. I got like internal CUDA heap allocation errors last night when I tried to run the sweeps. Look at that. 15 seconds for a 5 mil parameter run. Seg fault. There you go. So that seg fault, when I queue up all the jobs right for a sweep, will just kill the sweep runner, which is the annoying thing. Exceeding memory. Why? This is the end of the run. It's when the program terminates that it seg faults. Okay, that is possible for the CUDA heap errors, yes, but it still seg faults. I'll try to see if the sweep runs even with the seg faults. I doubt it, though. Doesn't seg fault. Yeah, no worries. I'll give you, I'll finish this up. I'll try to get you the container today. And, then you'll be able to play with it. I'll get you, like, a container that runs this thing nice and really fast. Sure, see you around. Let's give us better density estimates. Control densities. Sim density is 0. Well, that's not right. Okay, and we'll put a breakpoint here. Okay, 80% is what we want, right? How is a world done? Oh, because I'm dumb and I left a breakpoint in. Oops. For folks on YouTube, all of this stuff is free. It's open source. All the stuff from today will be committed up by tonight. It's all in GitHub AI, GitHub Puffer, right here. And if you want to support the project, just give it a star. Helps me out a ton. Okay, so we get the sim density. Oh, you're still around, Eileen Key? What was I doing with sim density versus data density? Triple density. I think control density is what we need, right? No, wait, I was doing... A little late with that one. Let's just do data densities. That tells us what we need to write. Yeah, because it's always going to be 100. That's fine. And we don't need... This is over... Yeah, this is all we really care about. Sim densities. Yes, num live. Live over. Nope. Okay, this is good, right? Hmm. 0.4. So 40% data density. We could substantially improve this. Well, I mean, we have it running now at least, so... How big is the batch is going to be? It's a lot of agents, dude. Let's see about this. Like big batches. Good, out of memory. Do I offload? Or do I go smaller? Still out of memory. Well, this is where we kill all Python. We it's still out of memory. I can try that to see if that works. Usually a lot of the kill ones don't actually work. Okay, so this does actually break, unfortunately. I think we're going to have to bring back offload. I don't know why it's this much memory. We'll do 500k batch for now. It's divisible. Yeah, okay. 16. This is kind of reasonable. It's just like too many environments for this. Look at this we got. Okay. There's stuff happening. $360k train. Let's fix some variables so that we can get good metrics. We'll get some good metrics. The goal for today is to have a sweet demo in which we just like essentially obliterate this benchmark through ludicrous scale, because we can train it nearly 10 times the speed of the original project. And then we hand the lab their, their nice new shiny version. And they're happy because they get a new shiny version that's just like stupid fast. And I'm happy because Puffer did a thing. And then we get 1 trillion Puffer stars. That sounds great. Old agent mask. Let's see if this works. Collisions go down. I think it's because they just don't do anything, though, because the goals go down. These are things that could be valid ranges, right? Mean reward per episode. Entropy is reasonable. Explain variances. Something weird is happening. Basically, they're not achieving goals. This one is weird. I'll have to ask him about that, but... Entropy crashing. Let's see. Update epochs 1. Lambda 5. Put this 2.1. Try with these params instead. Because I think they're just learning to not do anything. I'm going to use a restroom. I'll be right back, and we will continue. Okay. Um, yeah, I'm very suspicious of the data if this is not solving stuff. It'd be really nice to be able to run the Wannabe sweep, but first of all, let's be smart. Let's do like 20 mil here. We'll track this. And it's not going to be easy to get this down onto my main machine, though. I really should render it, though. Well, okay, we'll try a little bit not smart first. Just to see. It's going to be substantially easier if I can get this to work and then do the container stuff. So... SSH-X. There's no way this works, right? Inside of a container. I mean, I'll bite, but there's like no way this works, Linky. I know it's X forwarding, but I just don't think it'll work inside the container without me having to do some stuff. What's one that I have? Yeah, this doesn't work, Linky. Do you actually have forwarding working with the puffer boxes? That would be a very nice thing to have. We don't currently have that working as far as I'm aware. Look at inbox 6. Very good. More stuff for us. Trying to think, like, what are the obvious gotchas here? I actually don't see anything wrong here. Let's see what's reward. Well, that's suspicious that the rewards are that high on the first step, right? I'm trying to think about the possibilities. Let me try a more reasonable setting just initially, just to see. 64 worlds. Same exact shape. Reward goes down. Oh, wait. Maybe it was just hyperparameters. Well, this also I'd imagine is a hard scene. It has 60 agents on it, right? Definitely something happens here. So, I mean, that means that it's got to be able to learn something. So we really need the automated sweeps now. What I'm taking from this. The sweep should just discover everything. But now, the seg fault on exit is rough. Yeah, look at this. It's gonna... This will be good. I could try their hyperparams. I don't know if that would be any better. Even though this is our slowest run, this is still faster than their training setup. I don't want to bet that this is just going to be hyperparameters, and I'll be wasting my time if I spend more time when I can't tune it automatically. I think it's pretty darn likely. Pretty darn likely. Okay, so what we're going to do then is we'll add it as a hyperparameter. Yeah, we'll add it as a hyperparameter, but we got to still figure out the seg faulting thing. Maybe in the torch env we can see. There should be a close. Probably not here. Okay, is it in the base? There's no close. Is it? Maybe it's self.sim.close. We'll go look for it. How's this doing? I think I stopped this for now. This is like reasonable enough that I can tell that it's learning stuff. Learned something. The mean reward per episode is weird though. Well, let's not do yeah, let's not go crazy over this. We don't need to track. See if we can find the close method. There's no close on this. Yeah, there's no close. Why would there be no close on this? We'll have to just try stuff. Trying to think what else we could do to find where to close this. I mean, this does not expose a close. Close. Yeah, so it's not explicitly defined. They have it in these wrappers, but they don't define it in the env. Yeah. Seg fault still. Can I sweep with a seg fault? If I do this. And is this like not releasing mem either? It is releasing memory. It's an improvement. We'll see if it breaks with the seg faults, or if it can continue as long as I don't out of memory the node. Yeah, well that didn't go well, right? Set CUDA heap size. You can sweep it with a seg fault and it should continue. But might not release RAM. Yeah, well, this isn't working. There's like no way around this either, unfortunately, because yeah. It's irritating. The best I could do would be a jank like random hyperparameter sweep without the nice graphs. Let's at least get the env binding done for this in the next like 30 minutes, and then actually I'm gonna take myself. Here's what I'm gonna do. I'm gonna take a quick break. I'm going to go make myself a shake. I'll be back in a few minutes, and then I will make it so that we can configure environment parameters as part of a sweep. I'll launch like a really basic janky random search because that's all I'm going to be able to do from here. And then I'll clean up all of this stuff and I'll push it, and then it'll be on them to get this thing to not segfault. That's a pretty reasonable request, I would say. Environment should not segfault on termination. And if they are able to do that, then we'll be able to do more stuff. Let me see. All right, I'll be back. Yeah. All right. I might have gotten ridiculously distracted, but I'm back. I don't know. Train of thought is just not there lately. I need some more sleep, probably. Let me check a couple things. Yeah. So let's start by fixing the environment file. Well, not that hard. Come on. This is hard coded. Max num object equals 64. Okay. Num worlds, Unixians. Let's replace all of this jank. Max num objects is wrong. It's supposed to be max cont agents. This comment is now redundant. Per scene. Bad suggestions. And then we'll do okay. Nope. And then we can also do dot yeah, this will work. That it? It looks good to me. Can we run this? Too many indices. Cool, this now works. And then what we get to do, sweep.parameters. Sweep.parameters.m.parameters dot max. No, we're not going to sweep the max cont agents. That's ridiculous. We're going to do num worlds. Worlds. We're going to do uniform distribution or log distribution. We'll do uniform distribution. And the min will be 16. Max will be 512. $20 million total time steps. Sweep metric will be goal achieved. Batch sizes are decent. Yeah, decent, I'd say. Well, let's see if this works. We can clean up a couple things. It's not really a puffer end visit. I just do this. Torch. Get rid of that. Cool. This now works. So what we're going to do is mode train back native and drive rack. This. And I can't even do this. It has to be mode sweep, which is disgusting. Which I don't even know if works because we do carb sweep so often. So we'll do sweep carbs. We'll just pick a random data point. You know, whatever. Okay. So we have a really jank sweep going. It's not going to get any of the nice wannabe features. Because it's just if the M didn't seg fault, we'd be fine. I don't know why this N freaking seg faults. I just want to make sure it actually does this. And then if this works, I'll start packaging all this up. And then you guys can get to play with it. As you can see, we have comfortably at least a train of, well over 200K here. It can go higher, it can go lower, depends. I've seen over 300K, I've seen even over 400K, though I don't know how real that is. The base starting was 50K from SB3. PufferLib plus optimizations. This has a simpler main network, but it has an LSTM, whereas theirs does not have, the original net does not have an LSTM. Let's see what happens when this run finishes. I don't actually know what will happen. $20 steps. It takes a little longer than it says, than it suggests with the time, because there's this extra, there's a like 10% extra at the end that does a high quality evaluation. Okay, it's synced. And then it fails. Okay, that looks good. It's disgusting and jank and whatever, but it works. Cool. We can add Yep, this is all we need. We're gonna have to authenticate stuff. Okay. And Forgot to set up caching. It's okay. We'll fix that. We also need to do some stuff with the mini data, right? Um, and then (48 to 64). We'll do biggest file. This will be filtered data. Filtered data. Filtered data. So I think this will now work to regenerate our data set for us. Yep. Okay. Get filtered data. We're good. Biggest file. So we're just going to commit like the small sample of data sets. Cool, this works. Filter data set. This I can push to my branch. Commit some stuff. Are you PRing? I don't know if they'll want this as a PR. They can have it if they want it. I am including it on the puffer tank though. We have our filtered version of the data set that runs very fast, or that lets you train very fast. We have the biggest file that we're training on. We have a really janky hyperparameter sweep running, but we got something. I'd say we've done pretty well for, 2-3 days work on this. We will still have to mess with the we will still have to mess with a few things though to make all this shit work. Not too bad. Okay, this is all set. It's, whoops. It's just env name true, right? So env LD library path, right? GPU cache. So we set these env variables. We clone it to puffer tank GPU drive. CD build make cool. Let's see. We set the env variables as well. Well, this actually looks like it built. We'll see how this goes. But we're going to update these builds. Probably we'll have to add the sim link. I don't know if we remember to do that. What else we got in the meantime? We got GPUDrive. So, this is what we're going to do. Did you ever fix the Madrona CPU issue? They sent me a thing on it. I got the GPU one running reasonably fast. What the heck? Which of these are... Why are these running for 60 million steps? No, these are two new. Yeah, it's gotta be... I didn't set these to run for 50 million steps, did I? I don't freaking know. Whatever, we'll see. Oh, I moved the data directories. Dope. Um... And we'll just do this for now. Drive slash, what is it, big file? Biggest file. Why have a big file when you can have the biggest file? Mini data slash biggest file. This looks good to me. Really? Does not exist? Okay. Right, it's right here. This work? Yay, it works. Carbs. Okay. So this is now pushed. And this one is also. So we're going to have to, let's make sure that we didn't miss anything because this is going to make us rebuild the container. We might want to just add these just in case. Okay. So this is why we had to be careful with this, because now we have this tank. Goal achieved. And we're going to hope this one works out of the box. And if so, we will send this on over to the lab and say, here is your, out of the box working experience. And then it's only 4 p.m., so I'll think of a couple other things to do maybe. Or maybe I won't, we'll see. Could always just go grab an early dinner and go to sleep at 7. That'd be nice. Be nice if they had a Pi package for the project, but I know that's pretty hard to set up. Pip install GPUDrive would be a really nice addition, but we'll do the second best thing, which is Puffer Tank GPUDrive. Okay. Push. We're pretty well set from this. A little bit of boring stuff with all of this, but I think we made out relatively well. We got decently dense data. We don't have ragged tensor support, but everything else is good. Technically, we have a little optimization we could do. Least complicated way to do X pass-through has been run SSH server from within Docker instead of the host machine. Big rips were had here. Yeah, that's rough. That's okay. I didn't expect you to have something easy. I do that type of thing all the time, where it's like I just spend a couple hours, see if it's doable, and then it ends up not being reasonable to do, right? Two gig push. We should have something real cool to post from all this. Does Cerebrass work? Does anybody know? Like, does their stuff work for training? I've seen them posted a few models of their own, but I mess with Will a bit. Entire timeline is just UK being ridiculous. Thank you, Twitter. PufferLib is up to date. What's the link syntax? Link to file to symlink. Dash GPU. Dev. Okay. And then done. Let's see if it works. Likely we'll have to rebuild depths a couple times, so we'll have to rebuild 2 stages to fix a few things. But you know, we're like hopefully an hour or less from shipping something. Shipping things is good. So some stuff didn't work. So why did stuff not work? This should have given me an error message, shouldn't it have? Let's see where this went wrong. Okay, so the variables did get set. So this is updated. GPUDrive.cpython make-j. It did not get renamed. Oh, do you see this? Freaking comment. Does that do it? Probably that breaks it, right? Would assume. Linky, are we at the Elite Four yet? Is that a thing we are at? How many more petaflops do I have to throw at this before it's at the Elite Four? No? Fuchsia? I thought we were already way past there. Shouldn't we be Gym 8? With script, are we at Gym 8 with scripts, at least? Do we have 8 badges anywhere? Oh, we are. Okay, that's freaking awesome. Do you know how far through it? That managed to beat the Elite Four, but never in a full run. Okay, that's freaking awesome. Yeah, okay. That's very, very close then. Failed to create symbolic link. That's what. Okay. Path to file. Wait, path to file. Path to link. Dot dot. Path to. Oh, because PufferLib isn't cloned. Okay, that's fine though. So path to file is puffer tank slash drive slash drive. Every major event acts as a filter. Yeah, there's got to be some sort of like thing to prevent the data from being bad because like agents are stuck. It's kind of a unique environment in that sense. Nobody's ever done like an env that is that long. I mean, if we wanted to do this as like a research environment, right? The way that we would do it, like that we would represent this is would just be like with a stupidly long maze, right? We just make like a really stupidly long maze. And then we'd see like, you know, well, okay, agents get stuck. What do we do? Yada yada. It's kind of the same thing, right? Day 3 is not terrible as well for this project. Day 3 out of the box GPUDrive support with like 4 to 6x faster training than the original. That's pretty good. Longer term exploration. It's not exactly exploration. It's not exactly the same thing because you're doing it. It's just that agents, like some portion of the agents are getting stuck. Like you could fix that immediately with state resets, right? Just reset every so often, just reset to the agent with the most event flags, right? Like capture state of that agent, set all the agents to that and go from there. Empty continuation line. Guy has swarming logic that swarms to the highest 5. I mean, I would suggest doing just like reset to the top N, yeah, and then don't use the scripts and see how far you can get if you want to do it without. That's kind of go explory. It's very restrictive because you need a simulator that can do that, but like honestly, if that's what it takes, like we can always just tell people, hey, we got to make sims that have fast state resets, right? Like if this ends up just being an engineering problem, I know how to build sims that can do that. It's not that hard. You basically just do what Pokemon does, right? Where like the whole state is one big chunk of contiguous memory, and then resetting state is just a mem copy. It would be slightly annoying, but I could build that sort of an engine for Puffer. Ultra performance state reset. Oops. Oop. Want to see how it performs with no scripts? I'll speed up my progress. Lack of events in fuchsia. I'm gonna get them to stay there. Yeah. Gotta say, it's really nice to be able to just give people Dockers and never have any setup issues. 4 days of training to get to that point. By init in fuchsia, they'll stay there. Playing the percent game. So, again, right, if you just reset to the highest event flag position, right, then they'll stay there. And you said that starting from fuchsia, you can get through the whole game. Seems like that would work, though I don't know what's wrong with that guy's thing. If he's already doing that, why hasn't he beaten it? Also, when did he say that he could solve it in a month? I want to know the time frame on that. Because usually the thing with engineers, right, is that you multiply by 2 and then you go up to the next place value. So like if he says 1 month, it would be 2 years. as the expected time. Okay. Bugs and seg faults. That's fine. Puffer tank should have the stable branch, not the dev branch by default, right? Yeah. Definitely should have the stable, not the dev. I don't need to maintain 2 containers either, just for people to switch branches. Look at that. $200K. Let's see if this is really any faster. If it's not substantially faster, I'll leave it on 64 default. Claim 200K and be good. Let's 250. Okay, I think I just leave it on this and claim 250. Okay. Dot cache. Root dot cache nvim. I have to Docker. I mean, Okay. This will rebuild. I will be able to push this. I'll be able to be done early. Get myself an early dinner and go to sleep at like 7 or something ridiculous. And get good sleep. I'm tired. I keep finding stuff to fix. Gets rid of one warning. Or one like annoyance for users. Every minor annoyance you remove is a huge win. Yeah, that's nice. I got it working. Okay. Last rebuild. I hope it's the last rebuild. Move this below here. The real question is, what do I go get for dinner? I'm going to be done by 5 for once. Well, not quite. A little over. Not much, though. So yeah, for folks here, the plan is we're going to ship this. You all will be free to try it if you want. It'll be super easy to play with. All the crazy cursed things have been fixed out of the box. You can play with it at 5x the original speed. 250,000 steps per second train. Million plus simulation. There will be hyperparameter sweeps as well. I will launch one of those. It'll be a really jank hyperparameter sweep though, because unfortunately we do not have the technology. This env has to not segfault. It does segfault at the end of training, which is fine for single runs. Not nice for sweeps. I have a hacky workaround script, but it doesn't let us do carbs. And I'm not gonna go through the whole day of effort to like make carbs work with a segfaulting env when the env just should not be segfaulting. If they really ask me to and they like really there's no other way around it, then maybe I will, but like the env should not segfault. It's just jank. Hopefully this makes more people use the env. And puffer. And puffer. Oh, I have to upload the image, don't I, before I... There. Push that. Perfect. Star Puffer. Yep. If you're watching and haven't started PufferLib, please go ahead and do. Helps me out a whole ton. Currently working for free, and stars on Puffer will make it easier for me to not have to work for free. All of this stuff will still be freely available, but will let me generate rev for Puffer as well. Stuff like that actually matters. Okay. Let's make like a dumb meme to go with this for tomorrow, for right now. Oops. Oops. Okay. Let's get some artwork. I don't know. Uh, let's see if it just makes something. It'll make something ridiculous. Copy image. Okay. We also need to go get our puffer fish, our favorite, our friend. Where's the puffer? Or esteemed members. That's funny. That's cool. Thanks, Yaxian. What do we think this'll... How do we think this'll do? Oops, can't link it. What's the Docker logo? A whale? Looks good. There you go. Cool. Well, they're looking at the seg fault now, which is awesome. Gonna have to get... Oop. Gotta go grab my API key. We'll call it a day. There we go. See? There is our hyperparameter sweep running. I think we're good for today. I think we're good. We'll see. I've got A-Rap here looking at one of the authors, looking at this tank. Let me go find some food to order on the side here. We're gonna end stream pretty soon. If anybody has any cool RL questions, I'll answer some stuff. But other than that, I should have kept the dingboard logo. My bad. Uh, You know, the really weird thing to me about California is just the lack of diners. Miss me a good diner. Well, Linky, diner would actually be a good way to get to know her. There you go. Your joke backfires for once. Wait, was that your joke or Linky's that he would constantly make? No, not Linky. What's the Nietzsche other guy? Nietzsche, not Nietzsche, right? Nietzsche? Yeah. Damn it. My head is like I'm just fried. My get mad. We'll order this, and if I don't have any replies, we'll just call it. Not bad. All right. Well, I think we're set for today. Not the most interesting stream, I know. Kind of just some chill dev. Um, Nothing crazy, but sometimes getting stuff working like this, you end up just doing a lot of like slow dev stuff, which is why I try not to have to do too much of it. I find it very boring, but the result is good for like 3 days of work. 3 like not crazy long days of work. We got this all working. It's fast. Need some hyperparam sweeps. They're looking at the seg faulting behavior for us for that. We can double check. The last thing we'll do today is I'll show the hyperparam sweep. It's kind of jank. But if we just go to projects carbs right here, go like this, right? You can just turn all these on, and then you can see, oh look, we have different runs here, and some of them will do better, some of them will do worse, and it'll run like 100 of these, and maybe it'll find something, who knows. Anyways, I think that's it. So yeah, I'm gonna call it an early day. I'm gonna get some food, I'm gonna get some rest, and then I will be back tomorrow and probably Saturday, maybe with more on this, depending on if there's anything new to do. If not, we'll be back to Atari, MOBA, other hyperparam stuff, and generally like getting ready for this big simulation update. Night, everybody.